Alcohols are compounds that are made up of an OH functional group. And this OH functional group is called a hydroxy or an alcohol functional group. Three types of alcohols that we talked about last time: the primary, secondary, and tertiary. We said whenever you want to classify alcohols, always look at the carbon that is connected to the OH and see how many carbons it is connected to. So if it is connected to one carbon, then that is considered to be a primary alcohol. If it is connected to two carbons in there, then this is considered to be a secondary alcohol. And if it is connected to three carbons, then this is a tertiary alcohol. Whenever you want to draw the condensed structure for the skeletal, every time you would need to read the structure starting from the left. And this one is going to be a CH3, a CH2, a CH2, and then the OH. No need for me now to put the OH in parentheses for this one because it is at the end. But whenever it is a secondary or a tertiary, I have to. So I'm going to start reading the molecule from the side, and that is a CH3. That is a C. It's an H, of course, because remember that every carbon is 4 bonds. So this is a hydrogen in there. It's a CH. And that CH is connected to an OH. So I'm just going to open the parentheses and put the OH in there. And then you have the CH2 and the CH3 that are connected to it. Same thing for the tertiary alcohol. Start reading from the left every single time. It's a CH3. This is a CH2. This carbon is a carbon. It's just a C in there. And this C has 2 CH3s on it. If you can see, it's 2 CH3s on it and an OH. I can write them in any order I want. So I can write the OH like this, and then the CH3s that are 2 in there. So I can write the CH3s and the OH, or the other way around. I can write the CH3 2 over here and then the OH. So I can end in the OH, or I can write the OH next to the carbon. It really doesn't matter because every single one of these groups that are in parentheses, they belong to the carbon. So the order doesn't matter. With respect to phenols, these are compounds that contain a cycle, and that cycle, it's a benzene actually. It has 6 carbons in there, and then the OH, the oxygen, has 2 lone pairs. So the oxygen is going to be an sp3 hybridization. Why it's an sp3? Because the oxygen has 4 groups around it. It's 1, 2 lone pairs, and then 2 bonds in there. The bond between the oxygen and the hydrogen, and the bond between the oxygen and the carbon. The double bond equivalence of the phenol. So the DBE of the phenol is equal to 4, because benzene is a DBE4. It has 3 double bonds in there and a cycle. So the DBE is equal to 4. Whether I write the phenol as a cycle and a circle in the middle, or I write it at 3 double bonds in there. We said last time that the double bonds are anywhere on the benzene. So these two are going to be the same in there. Now, with respect to the carbons in there, I know I have 6 carbons, and every carbon needs to have 4 bonds in there. This means that I have 1, 2, 3, 4, and 5 hydrogens on the benzene cycle. This is going to end up having every carbon being an sp2 hybridization. So every carbon, this is a planar, it's a planar geometry. So every carbon is an sp2 hybridization. Why? Because this carbon has 3 groups around it. Let's highlight the groups. So the hydrogen, this is a 1 group, this is the 3rd group in there. So that is 1, 2, 3. So this is why it is an sp2 hybridization. This means that this carbon has a p orbital. And this carbon has a p orbital, and those two p orbitals, they overlap to make the pi bond in there. As we said, that this oxygen in there is going to be an sp3 hybridization. Guys, remember that when oxygen has two bonds and two lone pairs in there, that its charge is 0. And when oxygen has just one bond and the three lone pairs in there, its negative charge is, or its formal charge is going to be negative. And when oxygen has three bonds and a lone pair, then its formal charge is positive. So you range from a 0 formal charge to a positive to a negative based on how many groups are there around the oxygen in there. Now for the ether, there are two types of ethers. This is the ether functional group. So the ether functional group is the OH. The phenol functional group is basically the benzene and the OH. So the benzene and the OH, both of them, we call them phenols in there. Ether is the oxygen. So the functional group is the oxygen. You have two types of ethers. You have a symmetrical or unsymmetrical ethers. Symmetrical ethers have the R's around the oxygen the same. Unsymmetrical ethers, they have them different. When I draw the condensed structure for the ether, then I would need to start always reading the molecule from the left in there. So I do have 4 carbons in there, so I'm going to start with the CH3. I do have 3 CH2s here, so I can condense them as a CH2 and the 3 of them. And then I do have my oxygen, so that oxygen is not a CO, it's just an O. And then next to the oxygen, I have a CH2 and the CH3. Same thing with the symmetrical ether in there, but with the symmetrical ether, because the R's are the same, then I am going to go ahead and to draw just one side, put in parentheses, put 2 in there, and those 2 are around the oxygen. This is called a diethyl ether, and it is a solvent that we use in organic. Now, in order to name alcohols, we're going to follow the same rule as the alkanes. So the alkanes are going to be our base in there. We're going to choose the longest carbon chain, and that carbon chain needs to contain the alcohol. There is a trend all the way here at the top. This is the priority order. And as we introduce more functional groups, I'm going to go ahead and add to this order. So far, we have introduced how to name alkanes, alkenes, and alkynes. We said that alkynes are higher priority than alkenes, so always the ending is in the triple bond. Now, whenever the alcohol is present, your ending has to be in the alcohol because the alcohol has a higher priority than the alkyne. So the OH of the alcohol is going to get number 1 every single time. So we're going to choose the chain that contains the OH and always start numbering from the OH in there. Give it the lowest number. This is 4, this is 5, and this is 6. And the name is going to be, we know that this is a hexane. So the rule says that whenever you want to name any alcohol, we're going to drop the E of the alkane, and we are going to add an OL in there. Always drop the E and add an OL. Why do we do this? We don't keep the E because the oxygen, the O, it is a vowel letter, and we cannot have 2 vowel letters that are next to each other when we do the naming. So this is why we drop the E and we put an OL. If the OH is on carbon number 1, we just drop the 1. We don't say 1-hexanol, we just say hexanol in there. So the name for this one is going to be hexanol. Same thing in there. We're going to choose the longest carbon chain, and that longest carbon chain is always needs to include the functional group. So that is the longest carbon chain. We're going to start by giving the OH the lowest number, and then we look at the other substituents. So I'm going to start numbering from this side to give the OH the lowest number. This is 5, and that is 8 carbon chain. The OH is on carbon number 4. So I know that my ending is going to be 4 dash, and it's going to be an octane. I drop the E and put an OL. So it's going to be 4-octanol. I have to number where the OH is. And then I do the substituents. I arrange the substituents in alphabetical order. Here I do have an ethyl as a substituent. I don't have any other substituents, so the name is going to be 4. It's going to be ethyl. And then for octanol, I could include the 4 between the octane and the O. So I can do 4 ethyl. I keep the 4 ethyl in there, and I put an octane and put 4 and put an OL. This means that the OH is on carbon number 4. Use whatever method you like. Both are correct. For this one, again, you choose the longest carbon chain with the functional group. See how many functional groups I have here. I do have all the OHs. So my longest carbon chain needs to include all the OHs. Even though it's the shortest, I don't care. It has to have all the OHs in it. So I'm going to choose my longest carbon chain with all the OHs. And I'm going to start by giving the first OH the lowest number in there. This is the chain over here that contains all the OHs. So that is going to be my parent chain. And my parent chain here, it's carbon 1, 2, 3, 6, 7, 8. This is not 10. I have 10 carbons in there. So I know that this is going to be named as decane. Now here's the rule whenever I have more than one OH. Whenever I have one OH, I need to use the prefixes di, tri, tetra, penta, etc. Here I have 3 OHs, so I need to use the prefix tri in there. And whenever you have more than one functional group, you don't drop the E, because the tri is between the E and the ending of the alcohol, which is an OL. So the ending is going to be tri-ol. So the tri is in between. So no longer I have the E and the O next to each other. So I will keep the E. Okay, very important. Whenever, this is the only case where you keep the E in there whenever you have more than one OH. So we're going to keep the E, and the name is going to end in decane, tri, all in there. Of course, I have to specify where my OHs are on the decane chain, and my OHs are on carbons 2, on carbon 6, and on carbon 8. I have 3 OHs, and this is why I am using the prefix tri in there. And then you put your substituents. Arrange your substituents in alphabetical order. This is an isopropyl and this is an ethyl. Iso, I is part of the name. You have an ethyl, E comes before the I. So the name is going to be 5 ethyl, 4 isopropyl dash, and the rest of the name. This is over here a more complex example of how to name alcohols with longer chains in there. We're going to follow the same rule. So whenever you have more than one OH, I don't care to choose the longest carbon chain. I care to choose the chain that contains all my alcohols in there. And that is going to be, I'm going to start from here, and I'm going to keep moving in there until I cover the second OH. So this is going to be my longest alkane chain. Start numbering your chain. Give your first alcohol the lowest number. I'm going to start numbering from here because this is the side where the first alcohol gets carbon number 3, which is the lowest number in there. This is 5, 6, 7, 8. This is 9. I do have 11, and then the rest of the chain, which is 16. So I have 16 carbons in there. I have 2 OHs, so I know that 16 is a hexadecane, okay? So that is going to be hexadecane. I'm going to keep the E as I did over up there. As I did up here, I kept the E. I'm going to keep the E in there. And this is a 2OH, so it's going to be a diol. Where are my OHs? They are on carbons 3 and 11. Here you go. This is called the parent name at the end. So this is very important to take care of it, first, and then I'm gonna start naming my substituents. Let's go ahead and highlight our substituents here. So I have a tertiary butyl at 8. T is not part of the name. So that is tertiary butyl. B, I need to look at B in alphabetical when I arrange in alphabetical order. And then I do have 2 ethyls in there, and I do have 2 methyls in there. So let's arrange them in alphabetical order. B comes first. So the name is going to be 8 tertiary butyl, and then 6,6 diethyl. And on carbon number 9, I have a dimethyl, okay, and then the rest of the name. When naming alcohols as common, we agreed that common names, these are used for very small alcohols in there. And normally, IUPAC is a better way to name alcohols, but when it comes to those small alcohols, it's easier to name them as common, especially those 2 in here. So to name an alcohol as a common, what you do is you end the name in the alcohol. So you count all the carbons and you end the name in the alcohol. Let's have an example over here. So that is I know that this is an isopropyl group, right? So that is going to be an isopropyl and an alcohol. So it's an isopropyl alcohol. Always end in alcohol. So that is going to be an isopropyl alcohol. Okay, isopropyl alcohol, there's a space in here between the isopropyl and the alcohol. Just keep a space. Now, if I want to name it as IUPAC, it's as usual in there. Give the OH the lowest number. If you number on any of the sides, it's going to be on carbon number 2. So it's going to be 2 propanol. And I can also name it as an isopropanol. Any one of those will do, as long as the ending in the OH. See the difference between common and IUPAC? IUPAC, you end in an OL for the alcohol. Common, you end with the alcohol. Same thing here. This is a tertiary butyl alcohol. Okay, and for the IUPAC, I'm gonna choose my longest carbonate chain. I'm going to give my OH the lowest possible number, and that will result in a CH3 as a substituent on carbon number 2. So the name is going to be 2-methyl 2-propanol, and also I can name it tertiary butyl. Same idea when you are naming cyclic alcohols. The difference is that if these are the highest priority functional group, then in this case, the OH needs to always gets the carbon number 1. Okay, not the lowest number, it always needs to get carbon number 1 in there. So when I want to name this, the cycle has to end in the name. So the name is going to be cyclo, and then you put your alcohol in there. So it's going to be cyclo hexanol. I don't have to say 1 cyclohexanol, so saying 1 cyclohexanol is wrong. So please drop the 1, and the name is going to be cyclohexanol. Cyclo is a must in the name, and that is included in the parent name, because if you dropped cyclo and said hexanol, hexanol is a chain of 6 carbons. This is 1, 2, 3, 4, 5, and 6, and then you have the OH. So see the difference between hexanol and cyclohexanol? It's a very big difference. So please make sure whenever you have a cycle to include the cycle before the parent name in there, and that will be included all in the ending, which is actually the parent. If you have substituents in there on the cycle, then make sure to give those substituents the lowest possible number after you give the alcohol the lowest number in there. And in this case over here, if I go 1, 2, 3, or if I go 1, 2, 3, the substituents are going to have the same number in there. So in this case, I go by alphabetical order and give the first alphabetical order the lowest number. The chlorine is the C in the chlorine is the first alphabetical order. So I'm going to go like that, 1, 2, 3, 4, and 5. And the name is going to be 3. Chloro. On 5, I do have a methyl group in there. And then my ending is going to be a cyclohexanol. No, don't put one cyclohexanol or else the name is going to be wrong. Same thing over here. Always start by numbering from the OH. Number from the OH because this is going to be your highest priority group. In there, so that's going to be 2, the 3, and that is 4. On 4, I have an ethyl, and on 3, I have 2 methyl groups there. E comes first, so so the name in there is going to be 4. It's going to be ethyl, and on 3, 3. I do have a dimethyl, and then your regular ending, which is cyclohexanol. Make sure that your name includes all the substituents. And here I do have 2 methyl substituents and an ethyl substituent in there. Notice that I went this way in numbering because this way gives all the substituents the lowest possible number rather than going this way. Because if I go both ways, the ethyl is going to get the same number, which is 4. So I want also the 2 methyls in there to have the lowest possible number because these are going to be my first substituents after the OH. So we talked about geometrical isomers earlier, and we said that whenever you have only 2 substituents on the cycle, not more than that, only 2 substituents in there, those 2 substituents can assume either a cis orientation or a trans orientation, and we call those 2 stereoisomers. The type of stereoisomer is called the geometrical isomers in there. So this is called cis, and this is the only time I use cis and trans in there whenever I have 2 substituents on the cycle and these 2 substituents are on the same side. Whether they are both up or both down, that is going to be cis. And then it's going to be 1, 2 cyclohexanediol. And again, as I said, whenever you have more than 2 OHs, please keep the E in there. But please separate the E from the OL by the prefix, which is the di. And there, this one is a trans 1, 2 cyclohexanediol. There's another way whenever you want to draw your cyclohexane. Another way to do it is, and those 2 are the same in there. So instead of drawing it like this, I can simply draw it this way. And if I draw it this way, I can use the wedges and the dashes to express the OHs being on the same side, or I can use lines. So here in this orientation or in this drawing, I am using just lines. And in the lines, I am showing that the OHs, both, they are pointed down in there. So if they are pointed down, this is going to be behind in this case. It's exactly the same as if I have my structure in there and the OHs are behind in there. And this one is exactly the same as if my OHs are in front. Okay, it's just a different way of expressing it. Instead of showing the wedges and the dashes, I just show solid lines. But here now the solid lines, I show it in a planar geometry, and the solid lines in there, they are basically pointing in the same direction. Either both are down or both are up in there. Now I know that the cyclohexane is not planar because every single one of these carbons is an sp3 hybridization in there. But the way that I am drawing it, it's like I am assuming that all the carbons they belong to the same plane, although they don't. Okay. Same thing for the trans isomer. I am showing the OHs. One is down, the other one is up. These two are going to be the same representation in there, and these two are named as trans 1,2 cyclohexane. Point is whether you show the trans as wedge or dash, or you show the cycle as planar in showing the bonds of the OH as solid lines, both up and both down. Both of these are different representations of a trans isomer. Now, for benzene connected to an OH structure, this is called phenols. Phenols are common names for the IUPAC name hydroxybenzene. So this is a phenol, and it goes by the phenol. The IUPAC name for this one is going to be a hydroxybenzene. There's another name for this one, which is a benzene O in there. So all what you need to do just to drop the E of the benzene and put an OL. This is another name for phenol. But normally, whenever we are working with a benzene connected to the OH, we go by its common name because it's easier, and we always name it phenol. So you would see always that for complex molecules, something like this, always the ending is going to be in the phenol. When you are naming any multi-substituted structure in there, always the parent name has to end in the common root. And we've talked about this before. So here what you have is the OH functional group, the chlorine and the bromine. The OH is going to be the highest priority. So what you do is you highlight the benzene together with the OH in there. And when you do this, the ending is going to be in both of them. So the ending is going to be in phenol. That makes it easier whenever you want to name. This means that your numbering has to start from whatever you ended up with, the functional group that you ended up with which is the OH. So your ending has to be in the phenol, so the OH gets the lowest number. If the OH gets the lowest number, then you're going to start numbering in the sequence to give the second substituent the lowest number. So that is going to be 2, that is going to be 4 in there. Because I do have a benzene with 3 groups, I cannot use ortho, meta, and para. Pay attention to that. I only need to use numbers. I'm going to arrange the other substituents, the chlorine and the bromine, in alphabetical order. The bromine comes first, so the name is going to be 4-bromo. And on carbon number 2, I have the chlorine, and then that is going to be phenol. There is no space between the chlorine and the phenol. Now, for the for this example here, again, between the NH2 and the NO2, the NH2 is going to be a higher priority there. So that one is going to be a higher priority. And because it is a higher priority, I'm going to choose it together with the benzene and end the name with its common root and give that NH2 the carbon number 1. So the common root here in this case is going to be NLE. These names, you have to know them for the different benzene substituents. Then NO2 is going to be nitro in this case. So the NO2 over here, I'm going to name it as a nitro. Because I have 2 substituents on the benzene, I can use the ortho, the meta, and the para. Now the nitro is on carbon number 3 of the benzene, so I'm going to use meta in this case. Using ortho, meta, and para is better than using numbers whenever you have to substituents on the benzene. So the name is going to be meta, nitro, and of course there is no space between the nitro and the aniline, so I'm just going to go ahead and bring everything over here. It's going to be meta nitro aniline. If you don't want to use meta, it is fine in there, but it's better to use the ortho, meta, and para. But I can use the 3 nitro and aniline. Because by doing this, I know that the NH2 definitely, since it's at the parent name, it is on carbon number 1, so the nitro is going to be on carbon number 3. Please differentiate in the name between the NH2 and the NO2. The NO2 is always given the name nitro in there. The NH2, if it's not a priority, it's given amino. I do have the list of the priority of the groups for the benzene, and this is listed over here. So the phenol has the higher priority, and then the aniline, and then the toluene, and then the methoxybenzene, which is the anisole in this case, and then the nitrobenzene is the least priority. So that is the anisole in there. I have toluene. This is aniline, and then phenols. Phenols are the highest priority. Again, I have multi-substituents on the benzene. Between the NH2 and the OH has a higher priority in there. You can add this trend on a cheat sheet and put it and use it for the exam. No problem with that. No need for you to memorize it. Okay. So the phenol is going to be a higher priority. So I'm going to start numbering from the phenol. And then I'm going to give the second substituent the lowest number. So I'm going to move this way. This is 3, 4, 5, and 6. I do have my ethyl group. I do have my methyl group. So this one is the ethyl. I do have my methyl in there. And notice that the NH2 now is a substituent. If it is a substituent, I'm going to name it as amino. Please see the difference between the amino and the nitro in there. We arrange in alphabetical order. Amino is going to come first, and it is on carbon number 5. So that is going to be 5 amino, 2 ethyl, 3 methyl, and the ending is going to be phenol. You guys pay attention when you have a cyclohexane versus a benzene. So the ending in this case is going to be in the cyclohexanol. It's going to be the same name, but the ending is going to be different. So the name here is going to be 5 amino, 2 ethyl, 3 methyl, and then the ending is a cyclohexanol. Okay, we're still starting with carbon number 1 of the cycle in there, and then following the same rules in the name.